Hello. So our question is, what is the spring constant of your car? So the problem here is we don't know the original, the spring at equilibrium. So to solve for the spring constant of our car, we needed to figure out an equation to find K adding mass to the car. So in another situation, we have a spring hanging from the ceiling attached, or a mass hanging from the ceiling attached to a spring. And we don't know the equilibrium length, so we call x naught, and then we call the length, the stretch of the spring, x1 with the mass on it. So to figure out the equation with one mass, we can go mass 1 times g equals k times x1 minus x naught. And this can simplify to mass 1 times g equals kx1 minus kx naught. And that is for one mass on the spring. Then, if we were to add two masses to the spring, we can get the equation m1 plus m2 times g equals k times x2 minus x naught. And that's for the stretch of the spring with two masses on it. And then we can simplify that to m1g plus m2g equals kx2 minus kx naught. Now, if we were to solve this equation for k, we know that m1g equals kx1 minus kx naught. So we're going to plug in kx1 minus kx naught for m1g, and get kx1 minus kx naught plus m2g, that is a 2, equals kx2 minus kx naught. We see that the kx naught cancels, and that leaves us with m2g equals kx2 minus kx1. Now, we can simplify this to m2g equals k times x2 minus x1. And then when solving for k, we can get k equals m2g over x2 minus x1. So then we never actually have to know the original length of the spring. So now if we're solving this for a car, we just used an example of one of our cars, and we said that the mass is 1,716 kilograms, and then we're adding a 68 kilogram human into the vehicle. So originally, with just the car on the spring will stretch 0.1 meters. And then adding the human into the car, it'll stretch 0.01 meters. So then, if we know k equals m2g over x2 minus x1, we can plug these in. However, there are going to be 4 springs on a car, so we're going to add a 4 over here. And then we're going to have k equals m2g over 4 times x2 minus x1. So now if we plug in the numbers, we get 68 kilograms times 9.8 meters per second squared divided by 4 times 0.1 minus 0.01, and k will equal 1 1,851 newtons. Thank you.